Hello everyone, I am Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. In this December month lecture series, we are going to discuss about modeling of biological system. Here I have chosen the topic lung model. See here, this represents the linear model of circulatory system. Here, this diagram, this circuit is called as linearized description of lung mechanics. Here we use the elements PAO, RC, QA, Q cube minus A, PAW, CS, RP, PA, CL, PPL, CW. Okay, the airways are divided into two categories. The larger are central airways and the smaller are peripheral airways with fluid mechanical resistance equal to RC and RP respectively. Air that enters the alveoli also produces an expansion of the chest wall cavity by the same volume. This is represented by the connection of the lung CL and the chest wall CW compliances in series. Okay, here we have resistance RC and RP as well as CL and CW compliances in series. CL by the connection of lung CL and the chest wall CW. Okay. Here, what is this P? P is pressure. Pressure developed at different points of this lung model are PAO at the airway opening, PAW in the central airways, PA in the alveoli and PPL in the pleural space. These pressures are referenced to PO, the ambient pressure, which we can set to 0. Okay. See here, a given property of the lung model is assumed to be concentrated into single element. The total resistance of central airways lumped into single quantity RC, even though in reality the central airways are comprised of the trachea and few branching generations of airways, each of which has a different fluid mechanical resistance. Similarly, a single constant CL is assumed to represent the compliances of the lung, even though the elasticity of lung tissue varies from region to region. Here, the volume flow rate of air entering the respiratory system is Q. Then the objective here is to derive a mathematical relationship between PAO and Q. Q is our output. C. From Kirchhoff's second law, applied to the node PAW, if the flow delivered to the alveoli is QA, then the flow shunted away from the alveoli must be Q minus QA. Applying Kirchhoff's first law to the closed circuit containing CS, RP, CL and CW, we have formula like RPQA plus 1 by CL plus 1 by CW integral QA dt is equal to 1 by CS integral Q minus QA dt. Applying Kirchhoff's first law to the circuit containing RC and CS, we have PAO which is equal to RCQ plus 1 by CS integral Q minus QA dt. Here the formula becomes d square PAO by dt square plus 1 by RPCT dPAO by dt, which is equal to RC d square Q by dt square plus 1 by CS plus RC by RPCT multiplied with dQ by dt plus 1 by RPCS, which is multiplied with 1 by CL plus 1 by CW into Q. Okay, with the help of Kirchhoff first and second law, we can derive this formula. Here CT, total capacitance, which is equal to 1 by CL plus 1 by CW plus 1 by CS. C. By analyzing lung model, we consider a simplified version of linearized lung mechanics model. In addition, however, we will also add an inductance element L that represents fluid irritants in the airways. See here, the model is converted into simplified version PAO, PA, ventilator, we have L are inductance, resistance, capacitance and we have PO. Here PAO minus PO which is equal to L dQ by dt plus RQ plus 1 by C integral Q dt by applying Kirchhoff's laws. Here PA minus PO which is equal to 1 by C multiplied with Q dt. Here PAO which is equal to LC of d square PA by dt square plus RC of dPA by dt plus PA. Here our final one, PA of S by PAO of S, which is equal to 1 by LCS square plus RCS plus 1. This is a simplified model of lung. PA of S by PAO of S, which is equal to 1 by LCS square plus RCS plus 1. See how it is converted. PAO, which is fed into 1 by LCS square plus RCS plus 1. The output is PA. In diagram B, PAO, which is fed into summing point plus and here the element 1 by LCS square plus RCS plus 1, output is PA. Here the feedback is K is our constant. PA of S by PAO of S minus KPA of S, which is equal to 1 by LCS square plus RCS plus 1. Here our final output is PA of S by PAO of S, which is equal to 1 by LCS square plus RCS plus 1 plus K. Thank you.